Hi, we are Group 3. We have chosen ISOPRENE as our molecule to analyze for SIC1001 assignment. My name is HUSNA.
My name is DANIA.
My name is ZIRUI.
I'll be presenting for part module of ISOPRENE, which consists of physical and digital module. And then for discussion about ISOPRENE, I'll be describing about its atomic structure, electron configuration, and valence electrons.
So for the next part, I will be presenting about the position of atoms in isoprene in the periodic table. And for the next part, I will be explaining about the chemical bond and properties in isoprene. I will analyze the type of chemical bonds that is present in isoprene and how does the bonding influence isoprene properties and structure.
And for my part, I will present the application of the isoprene. I will present the application in the real world and the contribution of the isoprene into industry and everyday life and research.
So let's go to the first slide, will be presented by HUSNA.
The formula of isoprene is C5H8 and its IUPAC name is 2-methyl-1,3-butadiene. For the first part, we have decided to use both digital and physical models to analyze the molecules. For digital model, we have used MolView website. From the isoprene model, there are two double bonds which between carbon 1 and 2 and carbon 3 and 4. These indicate that isoprene is a branched chain unsaturated hydrocarbon. Both model shows that black color as carbon and white color as hydrogen. In addition, isoprene is actually a monomer for a natural rubber, which is isoprenite. For the second part, I'll be describing atomic structure, electron configuration, and valence electrons of atoms that involves in isoprene. Atoms that involves in isoprene are carbon and hydrogen. Carbon have 6 protons, 6 electrons, and 6 neutrons. From the 6 electrons, we can write electron configuration for carbon, which is 1s2, 2s2, and 2p2. It is important to follow Aufbau principle, as I provided in the slide, to write the electron configuration in the right way. From the electron configuration, we can determine the total valence electrons for carbon. The highest energy level in carbon is 2, so we need to add electrons from both s and p orbital of the second energy level in carbon to get the valence electrons. So the total valence electrons for carbon is 4. For the orbital diagram, I have drawn and inserted in our slide as provided. I will show you how to draw the orbital diagram based on Hund's rule. Hund's rule states that every orbital in a sublevel is singly occupied with 1 electron before any one orbital is doubly occupied. So this is the orbital diagram. We need to fill the electrons by energy level and by its orbital. Let me show you. So, first electron. This is the first energy level and s orbital. And then the second electron. This is second energy level. First, second. Then we need to fill the electrons until it reaches 6. This will be the orbital diagrams. Next, hydrogen atom. Hydrogen is the easiest molecule to analyze. Hydrogen only have 1 proton, 1 electron, and 1 neutron. The electron configuration for hydrogen is only 1s1, and the valence electrons for hydrogen is also 1. The orbital diagram is as provided in the slide.
Now, before we want to determine the position of a certain atom in the periodic table,
we have to know its valence electron, its highest number of occupied orbital, and the block of the atoms that belongs to based on its electron configuration. Let's start with carbon. Carbon has valence electrons of 4, which means carbon belongs in group 14 in the periodic table. Now, if you refer to the electric configuration of carbon, we can see that the highest number of occupied orbital for carbon is 2, and it is belong in p orbital. Therefore, we can determine that the period of the carbon located in periodic table is 2, and it is on p block because we have s block, d block, p block, and f block. So therefore, we can conclude that the position of carbon in periodic table is in group 14 on period 2. Now, for the next atom in isoprene is hydrogen. Hydrogen is a very easy atom that we can position in the periodic table. Why? Because hydrogen only has one valence electron, and we know that valence electron of hydrogen occupied at s orbital, which means it determines the position of hydrogen in the x block. We know that from the electron configuration, the highest number of occupied valence electrons is equal to 1 for hydrogen. That means hydrogen will be located at the period 1, at s block, and in group 1. So now we can conclude that hydrogen is actually located at group 1, period 1, and then at s block of our period. In this molecule, we can say that there is only one bond that exists in this molecule, which is covalent bond. The covalent bond exists between carbon and hydrogen atom in the compound. Now, how about its properties? So we know that isoprene has low melting point, is a volatile compound, soluble in water, colorless liquid, hydrocarbon. Why is it hydrocarbon? Because it only has carbon and hydrogen in that molecule. So why does isoprene has low melting point and volatile compound? This is because of the intermolecular forces exist in that molecule. In this molecule, the forces that exist is only van der Waals force. Van der Waals force is a force between two compounds of isoprene if the isoprene is in polymer. These weak forces, which is the van der Waals forces, causes this compound to have low melting point and volatile compound.
As an alkane, the isoprene can be application in industry, chemical manufacturing, medication, and laboratory research. In industry, it's a type of extractive from petroleum, which means it's primarily used to the production of gasoline and other fuels. These organic compounds are widely employed as a solvent in the chemical industry. They are used for dissolving and process other compounds, playing a crucial role in many chemical processes. For chemical synthesis, this organic compound serves as crucial starting materials for the synthesis of various organic molecules. They are utilities in the preparation of of diverse chemicals, including plastic, rubber, contain, and pesticide. There are also 3 types of compound, like polymer production. First is polymer production. These compounds are used in polymer reaction to produce various polymer and plastic. For example, they can be utilized in the production of polyethylene and polypropylene. Second is fluorine and fragrance. These aromatic hydrogen are often used in the food and perfume industry to impact specific smell and fragrance to product. And the next is pharmaceutical and medical application. Isoprene are component of some pharmaceutical employed in the field of medical and healthy care. The last is laboratory research. In laboratory setting, isoprene are utilized in various organic synthesis, reaction, chemical proprietary study, and the development of new material. In conclusion, ISOPRENE play vital roles across multiple industry, spanning energy, chemical manufacturing, pharmaceutical, food, and other fields.